Today's lesson is on volume of prisms. So let's go ahead and start with a key idea. And that is that the volume of a prism is the product of the area of the base and the height of the prism. So here we have a rectangular prism where the base is a rectangle. And here we have a triangular prism where the base is a triangle. Either way, we need to find the area of that base and then multiply by the height. Notice when we write this down in algebra, we have V equals capital B times H. It's important that that B is capitalized because that tells us it is the area of the base that we're looking for, a two-dimensional area. So let's look at our first example. We're going to find the volume of the prism, and we're always going to start with V equals capital B times H. And in this case, our base is 6 times 8. Length times width, and then our height is 15. Now, multiplication is commutative. It doesn't matter what order we multiply. You can use your calculator. It's 720 cubic yards. Our units are always going to be cubic when we're doing volume to show that it's three-dimensional. Here's our second example. We have a triangular prism. We'll still start with volume equals capital B times H. And this time, we need to find the area of this triangle, which is 1/2 times 5.5 times 2. Remember that the base and the height of a triangle need to be perpendicular to each other. The height of this prism is 4 inches. This is a little bit of a different orientation where it's kind of turned on its side. But in a prism, you always have 2 bases, and then the height will be perpendicular to those bases. So in this case, the height is 4, even though it's kind of laying on its side. All right, now we just need to simplify that, which is 22 cubic inches. All right, let's look at our next example. Here we have this application where we have 2 different designs of popcorn bags. They both have the same volume of 96 cubic inches. We need to find the height of each bag and then figure out which bag the theater should choose in order to reduce the amount of paper needed. So we're going to start with volume, then we're going to figure out something about surface area. So let's start with volume. We should have lots of space to work this through. For bag A, our volume is 96. And that equals the area of the base times the height. So the area of the base is 3 times 4, or 12. So 96 equals 12 times H. We'll divide by 12 on both sides and get the height equals 8 inches. For bag B, we know that, again, the volume is 96 cubic inches, and that's going to be equal to the area of the base times the height. This time, the area of the base is 4 times 4, or 16 times H. So we divide by 16 and get the height is 6 inches. Okay, so make sure you have that down. Now we have the measurements. Now we need to figure out the surface area of each of these bags to figure out which one uses the least amount of paper. Now when we find the surface area, we're going to find one base and the 4 lateral faces. We don't care about that top base because it's empty. There's no bag there. So let's go ahead and do the surface area part of this. For bag A, our surface area will be 3 times 4, that's the base, plus 2 lateral faces that are 3 by 8, and then there were 2 lateral faces that were 4 by 8. So our surface area is 12 plus 48 plus 64. So our surface area is 124 square square inches. Remember, now we're doing two-dimensional surface area, so it's in square inches. Let's go ahead and do bag B. And here we have the surface area equals, the base was 4 by 4. And then in this case, all 4 lateral faces are the same. So we have 4 sides that were each 4 by 6. So we can simplify that. That's 16 plus 96, or a total surface area of 112 square inches. So which one uses the least amount of paper? That would be bag B. All right, go ahead and try a few on your own. I'll see you soon.